All right, so we are reviewing together here. So number 1, 2, and 3 we did in class, but here we go. This is the fundamental theorem of calculus. They undo each other. It's a substitution question. When you plug in -2 and take the derivative, the answer is going to be 0. When you plug in x cubed, and then the hook comes from the bound, which is the derivative. Done. Ooh. Same thing here. Algebra gets plugged in with the hook of -2, subtract, then 3x squared, same work, and the hook. Here, plug in -2x and the hook, and then again, when you plug in a number and take the derivative, it's going to be 0. All right, a midpoint Riemann sum, and it tells you from 1 to 5. So to find the width, we're going to go 5 take away 1 divided by 2 rectangles. So each rectangle, that's 4 divided by 2, is 2. And then to find the height of it, we're going to use a midpoint. So a width of 2, and if you like, you can draw a number line that goes 1 to 5. So the first one goes 1, add 2 to 3, and the second one goes 3 to 5. So the midpoint would be at 2, the midpoint would be at 4. So we plug 2 in and solve it, and we plug in 4 in here and solve it, and that gives me my height, and I'm done. Here we're trying to find the volume with semicircles. So we're going to integrate from 0 to 2, and the formula for a semicircle is 1/2 pi r squared. Now the base here represents the diameter, so the radius is half the base, and the base is top subtract bottom. So that's top subtract bottom. So when you simplify it, it is just 4x minus x cubed. And there's the setup dx, and there's the setup for semicircles. Can you integrate? This requires a hook of 3. That means I need 1/3 for an adjustment. The hook goes away. We start with 1/3 and then add 1 to the exponent and add 1 to the exponent and divide from 0 to 1. So I'm going to simplify this. I'm going to put 1, and then 3 times 5 is 15, subtract. Then I'm going to plug in 0, same exact work over 15, and that's good. Whenever you integrate absolute value, you have to graph it. My suggestion is plug in 2, and what answer do you get? You get 1. Plug in -2, and -2 take away 1 is -3, but the absolute value of -3 is 3. Oops, there's 3. And then recognize where the vertex is. What makes this 0 is that +1. That's where the vertex is, and that gives me my 2 triangles. Recognize both triangles are above the axes, so both areas are positive. And then find the area of each one. So this here, the base is 3, and the height is 3. And the second one, the base is 1, and the height is 1. And that's a good answer. Here, we integrate by adding 1 to the exponent and dividing. Notice the 3's divide out, so it's just x cubed. So I'm going to plug 3, and I'm going to plug -2. And if you wanted to, you could answer it, but not necessary. It is 35. Turn the page. Number 9. This is a right-hand Riemann sum using this. So we're from 1 to 4. So if I could take the top bound, subtract the smaller bound, 3 rectangles, simplify it, the width of each one is 1. So if I look at the first rectangle, goes 1 to 2. So the one on the right is 2. So if I plug in 2 and you solve it, you get the answer 1. Then I plug in 3, and if I plug in 3 and solve it, you get 2. And then you're going to plug in 4, and if you plug in 4 and solve it, you get 5. And there's your answer. I know this is problem 7. It should say number 9. So which of the following is a trapezoidal rule for the same setup? So the same width, but the trapezoid starts with 1/2 the formula, then the width. All right, the first height here, when you plug in 1, the answer is 2. And then we double the next height, which is 1. And then we double the next height at 3 is also 2. And then the last height at 4 is 5, and we don't double it. So that's the trapezoidal rule. 1/2 the width, the first height and the last height you don't double. All the middle heights you do double. Number 11. I want to integrate off a graph, so I need to find the area of it. So this area here is a semicircle. That's 1/2 pi r squared, and the radius here goes from 0 to 3. It's 3. Then it's going to be negative because this triangle here is below the axes, and it's 1/2. The base is 2, and the height is -4 or 4. Now, if you went plus and you made the height -4 because the y coordinate is -4, you get the same answer, just so you know. Done. All right, can we integrate these integrals? So I'm going to write it friendly. So to the exponent -3, the hook is -2. So to undo that hook is -1/2. It goes away. So it starts with -1/2. Then I'm going to add 1 to the exponent and divide. So these together, make +1/4. Oh, and we're integrating from nowhere, just plus c. So we don't have to simplify it further if you didn't want to, but we could also do this. So it's an indefinite integral, no bounds, so it's just plus c. Let's try this one, plus c. Again, can you make it friendly? That's to the -1/2. What's the hook here? Again, -2, so again we need -1/2, what it was over what it became. And then the hook goes away. We start with -1/2, and then we add 1 to the exponent. So -1/2 plus 1 is +1/2. You can just divide by 1/2 plus 2. Notice these halves do divide out, so it's really just negative that to the +1/2. All right, last one, number 14. You should try it first, right? Can you make it calculus friendly? Like, you should pause and try. That's to the -4. What's the hook here? The derivative here is 3. And so to adjust what it was a 1 over what it became, which is 3. This goes away. So we have 1/3. And then we're going to add 1 to the exponent. That's -3 divided by -3 plus c. You don't need to do anything more. That is -1/9, but that's pretty good. Turn the page. This is a u substitution because the derivative here does not match what's in front. So u is equal to x minus 1. X, if you add 1, is u plus 1, and the derivative of x is equal to the derivative of u. So we are going to make this friendly to begin with, but we're going to change the bounds. So to change the bounds, plug 2 in, and if you plug in 2, u, when x is 2, 2 take away 1, and then plug 1 in, and 1 take away 1 is 0. So we've now changed the bounds so we don't have to go back to x. So friendly, we have 4x, which is u plus 1. And then this, instead of u minus 1, instead of x minus 1, we have u. And instead of to the half, it's to the square root, we have to the 1/2. And then dx is just du. So there's your setup. Next, we're going to multiply. So 4 times u and 4 times 1. And we're going to continue to multiply to distribute. Recognize when you distribute here, you're adding the exponents. So 1 plus 1/2, that's 3/2. 4 times u to the half is 4u to the 1/2. Now we're finally ready to integrate this, which means we add 1 to the exponent. So 3 plus 2, and then divide, or the reciprocal. Same thing here. We add 1 to the exponent, so it's 3 over 2, and then I'm going to use the reciprocal, and then it goes from 0 to 1. So to make my life easier, I got 8 over 5. I'm going to plug 1 in first. And 8 over 3. And again, I'm going to plug 1 in. And then subtract. Now, if I plug 0 in, 0 times anything, this answer is just going to be 0. So there's your answer right there. All right, you got 2 more to practice with u substitution, so I think you should try. So press pause, and I want you to set it up, and then just press play for what you need. So I'm going to go u equals x plus 4. I'm going to write down what x equals, which is u minus 4. And I'm going to take the derivative of x is equal to the derivative of u. Press pause, go back. So where there's an x, I'm going to put in u minus 4. Where there's x plus 4, I'm going to put in u. And then dx is du. Oh, I need to change the bounds, right? So if I plug in 1 here, 1 plus 4 is 5. And if I plug in negative 2, negative 2 plus 4 is positive 2. So now we're going from 2 to 5, and I don't have to go back. One of these is a 4. This is a 4. Okay, so again, we're simplifying first. So that's 2u minus 8. And then I'm going to add the exponents, and then I'll do the calculus. So 2u times u to the 3 is 2u to the 4. Negative 8 times u to the 3 is negative 8, u to the 3. And now finally we're ready to do some calculus here. We're going to add 1 to the exponent and divide. We're going to add 1 to the exponent and divide. And we're going from 2 to 5. I'm not going to simplify this, so we're going to start with 5. 8 divided by 4 is 2, just to make it easier on me. That's 5 again. Subtract. If you plug in 2, we need parentheses. And now I'm going to do the exact same thing again, but just with 2. All right, one more chance. I need you to try this first, and then press play. Press pause. Oh, I'm not going to do it. Boom. So why did I notice? I stopped myself. First of all, I didn't want to solve for x with a quadratic. But second, I recognize this is different. So what makes this one different? When I find the hook here, the hook of x squared plus 2 matches that. That's 2x. It's what I need for the anti-chain rule. That makes this one different. So I'm going to make it friendly to the 1/2, but the derivative, that hook, are like terms, different than the other 2 questions. So it was a 3, and it became a 2, and then the 2x can go away. So we start with 3 over 2. We're going to add 1 to the exponent, and then multiply times the reciprocal, and it goes from 0 to 1. Notice this all crosses out. And so when I plug in 1, and when I plug in 0, and that's a good answer. All right, turn the page. All right, we're going to graph this. Y equals 3. And this is a parabola at 1, 0 that folds up. So it's probably wise to plug in. So if I plug in 1, the answer is 0. If I plug in 2, the answer is 3. And if I plug in 0, the answer is 3. So it's good to have like a few points that you know for sure, and it will help me with my bounds. So I'm going to then shade that area there that I just did. So I sketched it and I shaded it. How do I find the area here? So from 0 to 2, top subtract bottom. So the top is 3, subtract 3x minus 1 squared dx. There's my setup to find the area. Number 19, that was it. How do you find the average value of a function? And the answer is you have to integrate it. So I'm just going to integrate what I see. And then I divide by the difference of the bounds. So 3 take away 0. It's a simple setup. and then can you actually do it? So 3 take away 0 is 3, so it's actually 1/3. So I'm going to write that down. I'm going to integrate this. I'm going to add 1 to the exponent and divide. Add 1 to the exponent and divide. -1 is -x, and that's from 0 to 3. And then it just starts with 1/3. I'm going to plug in 3. And then when I plug in 0, the answer is 0. So there's your answer. And I don't need to simplify it. Then it says, find the value of x that takes on that interval. So like solve for x in terms of what it would look like. Oh, I'm not sure if I can do this. So I'm going to see if this is possible or not. I might have set up a question you need a calculator for. 27 divided by 3 is 9. 4.5, take away 3. I don't like this at all. So we got 6. That's 12 over 2. 9 over 2. What is that? 21 over 6. That's what I got. So 21 over 2 times third, 21 over 6. Then you would take your calculator, and it's not a calculator test, so I wouldn't ask you to solve an equation that you'd need a calculator for. But you would take out your calculator. Where's my calculator for fun? You would then go, and you go menu algebra solve, and you would type in x squared plus x minus 1 equals 21 over 6. Let's see if I did it right. Comma x. And is there an answer between 0 and 3? And it's 1.679. And there would be your answer. Calculator. But I'm not going to do that to you. Number 19. Find the average value here. Wonder if this will work. So again, we're going to integrate from 3 to 8. And it is x plus 1 to the exponent 1/2. We have no hook here. So all I have to do is divide by the difference of the bounds. So I have 1/5. And then if I integrate this, I add 1 to the exponent and do the reciprocal from 3 to 8. And I'm going to plug 8 in first. Subtract, plug in 3. And that would give me the answer I'm looking for. And then you would take the calculator and make it equal to that. Let's see if I can simplify this. I think I created a bit of a tough situation. But square root of 9 is 3 times 27 times 2. I got 54 over 3. 2 times square root of 4 is 2. Cubed 8 times 2 is negative 16 over 3. What is that? 38 over 3, and then 1/5 from that. So that's 38 over 15. And then you would take out your calculator and go the square root of x plus 1 equals 38 over 15, and then you would solve it. Again, I wouldn't ask you a question where you'd need a calculator or something that complicated to do. Alright, so I'm going to go menu algebra solve. And it's the square root of x plus 1, move the cursor, equals 38 over 15, and then comma x, and you get 5.418, and there's your answer between 3 and 8. Where the average value, that's where the average value of the function is and where it occurs. Crazy, right? Okay. Number 20. Find an equation that passes through. So you're given a derivative. So I'm going to integrate to find the function. I have to integrate this. And when I do that, the hook here is 2x. It was a 1. It became a half. The 2x goes away. And then I'm going to add 1 to the exponent and divide. Plus c. So if I simplify this and do the reciprocal is 2 over 3. Maybe that's easier to write down. So it becomes 1/3. and it goes through the point 0, 1. So this is what we have right now. So if it goes through the point 0, 1, we make it equal to 1, and where there's an x, I make it 0. And then I'm going to solve for c, and this is not going to be pretty. So I can't square root 2, so it's irrational. So I have 1/3 and the square root of 8. And then I'm going to subtract it. It's like, to equal c. So if I put it all together, that's what the function would look like. See if I have an easier question than that. I don't like the way that turned out. All right, we're going to try this again. So we have a derivative. Let's see if this one will work out better. So we have a derivative, and again, the hook. Now, the good news for this one is when I integrate this, the hook I need is there. So the derivative of x squared is 2x, so I don't need to make any adjustments. So when I integrate this, I add 1 to the exponent and then the reciprocal. I just need to go plus c. Then I'm going to plug in 4, 1, or 1, 4. So make it equal to 4. What happens if I plug in 1? Oh, this one's a lot nicer. So let's see how this would work. So I plugged in 1 for x and 4. Really focus in here. 1 squared plus 3 is 4. Then how do I simplify this? So 3/2 means square root 4, which is 2. And then 2 cubed is 8 times 2 is 16 over 3. And then subtract that to the other side. Get common denominators. And you get 12. Take away 16 over 3. So that's negative 4 over 3. And that's it. So the equation then would be 2/3 x squared plus 3 to the 3/2 minus 4/3. All right, let's try this one more time. Same thing. You should try this. Can you integrate this? Let's see if it works out. All right, so I did it friendly. The hook is 2x. It was a 3. And it became a 2. So then when I integrate this, this goes away. I start with 3 over 2. Add 1 to the exponent and then the reciprocal, plus c. So this completely crosses out. So that's what I'm left with. X squared plus 5 to the exponent 3/2 plus c. Plug in the point 218. So I'm going to make it equal to 18. See what this does. So 4 plus 5 is 9. You need to know how to simplify this. So the square root of 9 is 3. And then 3 to the exponent 3 is 27. Subtract 27 to both sides. So 18 subtract 27 is negative 9. And then our equation would be x squared plus 5 to the exponent 3/2, subtract 9. And you have it. All right, last page. These are all setup questions. Press pause and try it, then press play. So can you find the area of this region? Well, it's an integration question from negative 0.5 to 1. It's just top subtract bottom. So that's x squared plus 1 to the 3, subtract 0. dx. Done. Can you find the volume by revolving around negative 2? So negative 2 is somewhere down here. So it's pi. There's a space so that there are 2 circles. So the first one, top subtract bottom, is x squared plus 1 cubed. Subtract negative 2. When you subtract a negative, you can go subtract negative 2 or plus 2. The second one top subtract bottom would just be 0 subtract negative 2, and you have your answer, or 2, and it's done. Could you do it if there are squares? So these are known cross sections, no pi. So from again, we're integrating from negative 0.5 to 1. The formula for a square is base squared, and the base again is top subtract bottom. So it's just x squared plus 1 cubed. Take away 0, and that is a square. This one is revolving, where there's a space, so it's a washer, and this is just area. All right, last one. The graph to the right shows the velocity of a turtle. And what was the average velocity of the turtle between 2 and 7? So to find average velocity, we're going to integrate from 2 to 7, and then we're going to divide by the difference of that. So we're going to integrate the velocity and then divide by the difference. Now the question even just tells me, what is the velocity from 2 to 7? Integrating, it's 17, so you just go 17 divided by 5, and that's a good answer. But do we have units? Oh, meters per hour. So there it is. So there's the average value. If I just want to integrate from 1 to 7, they already said if you integrate from 2 to 7, the answer is 17. So I just need to integrate from 1 to 2. Like I just need this extra part to go from 1 to 7. That's just a rectangle. 2 times 3, and you have your answer. Just area. All right, last thing. Write a sentence. What does your answer in part B represent? Well, from 1 to 7 means from 1 p.m. to 7 p.m. The tortoise traveled. How do I spell tortoise? Did I do it right? Tortoise. Something like that. Traveled the total distance of. Can't spell. Total distance of 23 meters, because it's in meters. We got this. That's what that meant. All right, Mr. G Math over and out. Great job reviewing with me, and good luck on the exam. Keep studying. Don't give up.